On this channel, we provide useful programming information with practical code examples. This time, it's about web workers in JavaScript. You can learn about the concept of web worker, basic usage, and sample calculations for heavy processing. Enabling subtitles will make the code descriptions easier to understand. Web worker, in JavaScript, is a mechanism that allows code to run in a separate thread from the main thread. This allows heavy computations and long-running operations to be performed asynchronously, preventing the main thread from being blocked. By using web worker, the responsiveness of the user interface improves and the application's performance enhances. Let's take a look at the basic usage of web worker. A new web worker is created by specifying a JavaScript file. This code demonstrates the basic mechanism of using a web worker to request computation from the main thread and receive the result asynchronously. It sends 10 as a message to the web worker and receives 20 as the result message. The main thread and the web worker communicate by sending and receiving messages to request and receive processing results. Web worker provides the following basic features: post message and on message. Used to send and receive messages between the main thread and the web worker. Send data with post message and receive it with on message. Thread independence. Web worker operates completely independently of the main thread. Therefore, variables and functions defined in the main thread cannot be accessed. Required data needs to be passed via post message. Script import. To load external scripts within a web worker, use import scripts. Alternatively, you can also use import, as shown below. By specifying type module in the argument of new worker, you can treat the worker as an ES module and use the import syntax. Let's take a look at the differences between web worker and async functions. First, let's look at the features of web worker. Thread isolation. Web worker executes JavaScript code in a separate thread. This allows heavy calculation processing to be performed without blocking the main thread, UI thread. Concurrent processing. Using WebWorker allows JavaScript programs to perform concurrent processing in multiple threads. Message communication. The WebWorker and the main thread do not share data directly and exchange messages using postMessage and onMessage. Cannot access UI. WebWorker cannot access the DOM, so it cannot directly manipulate the UI. WebWorker is suitable for the following cases. It is suitable for heavy computation processes such as image processing, data analysis, and encryption. It can be used when you do not want to block the main thread. Next, let's look at the features of async functions. Simplifying asynchronous processing. The async function is a syntax to make asynchronous processing more readable, internally using promise. Single thread. All async functions run on the main thread. Therefore, you need to devise ways to avoid blocking the UI thread. Optimal for I/O operations. It is suitable for asynchronous tasks such as network communication and file reading, but not for heavy computation. Async functions are suitable for the following cases. It is suitable for network communication such as API calls. It is suitable for file reading and writing using browser APIs or Node.js. For CPU-intensive tasks, you can use WebWorker to reduce the load on the main thread. On the other hand, for network communication or I/O operations, you can simplify your code using async await. By combining both appropriately, you can achieve efficient asynchronous processing. Let's look at another usage example of WebWorker. Next is an example of offloading heavy computations. This code is an example of using a WebWorker to separate and execute heavy tasks like Fibonacci sequence calculations from the main thread. Next is an example of sending and receiving messages by specifying a task name. This code is an example of dispatching processing based on the task name in the message, with the WebWorker returning calculation results or errors to the main thread along with the task name. When using WebWorker, keep the following points in mind. Cannot access DOM. WebWorker cannot manipulate the UI or access the DOM. DOM manipulation needs to be performed in the main thread. Communication overhead. There is some overhead when exchanging data between the main thread and the WebWorker. This can affect performance, especially when exchanging large amounts of data frequently. Same origin policy. WebWorker scripts are subject to the same origin policy. Scripts cannot be loaded from different domains. Using WebWorker can improve the performance and responsiveness of your application, but it's important to use it appropriately considering constraints such as the inability to manipulate the DOM. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. This channel provides practical and useful information about programming. Subscribe to the channel and let's deepen our programming skills together.